Satellite orbits are designed according to the capacity and objective of the sensors they carry. Depending on their altitude, orientation, and rotation relative to the Earth, satellites can be categorized as geostationary satellites, polar orbiting on suns and synchronous satellite, and spy satellite. Geostationary satellite is an equatorial west to east satellite orbiting the Earth at an altitude of 35,000 km, the altitude at which it makes one revolution in 24 hours. These platforms are covering the same place and give continuous near hemispheric coverage over the same area day and night. These satellites are put in equatorial plane orbiting west to east. Their coverage is limited to 70° north to 70° south latitudes, and one satellite can view one-third of the globe. These are mainly used for communication and meteorological applications. GOES, Meteosat, Intelsat, and INSAT satellites. On June 19, 1981, India launched its first geostationary satellite called Apple. It was an experimental communication satellite launched by the ISRO. The Ariane Passenger Payload Experiment Apple was ISRO's first indigenous experimental communication satellite. Polar orbiting or sun-synchronous satellite. As the satellite orbits the Earth from pole to pole, its east to west position would not change if the Earth did not rotate. However, as seen from the Earth, it seems that the satellite is shifting westward because the Earth is rotating from west to east beneath it. This apparent movement allows the satellite swath to cover a new area with each pass. All the remote sensing resource satellites may be grouped in this category. Few of these satellites are Landsat series, Spot series, IRS series, NOAC-SAT, TIROS, HCMM, Skylab, and Space Shuttle, etc. Spy satellites are observational platforms that orbit the Earth in order to image its surface and to record audio signals for military and political purposes. They transmit their data to Earth where it is interpreted by specialists in centralized secretive facilities such as the U.S. National Photographic Interpretation Center in Washington, D.C. Spy satellites have been essential not only to military operations and the formation of national policy, but to the verification of arms control treaties such as SALT 1, SALT 2, etc. The four basic types of spy satellite are photo reconnaissance systems that take pictures in visible and infrared light, infrared telescopes designed to detect missile launches, radars that image sea or land even through cloud cover and in darkness, signals intelligence SIGINT satellites, also termed ferrets, which are optimized either for characterizing ground-based radar systems or for deep drafting on communications. Sometimes photo reconnaissance and SIGINT functions are combined in a single massive platform such as the US Keyhole series satellites. Although a number of nations has launched spy satellites, US and the Soviet Union are responsible for the greatest number. The Russian Federation, which inherited most of the Soviet Union space system after 1991, has been unable to afford the cost of adequately updating its spy satellite network. In contrast, the US has continued to deploy even ever more sophisticated systems in a steady stream. Thus, the majority of spy satellites in orbit today, including all the most capable units, are US owned. Early US spy satellites, Corona, Midas, Samos, the Gaofen 4 is the world's most powerful GEO spy satellite, launched in 2015, which can provide instant coverage of earthquake or typhoon hit areas to support humanitarian relief. It will also allow China to monitor strategic foreign sites such as WMD facilities and naval bases inside its observation box.